So now talking about 3D printing, it is basically, we can say, digital process. So here we use mechanical 3D printing machines, which is controlled digitally through computer softwares. So we use 3D printing to print a 3D model. So the technology can be used for different type of material, but when we use material as a concrete, we can call that as a 3D printing of concrete. Technically, we can call that as a, it is a digital fabrication process for cementitious material. So now talking about why we should study about why we should study about 3D printing. So the main reason is 3D printing minimize our material waste in a construction. So traditional construction method produce a large number of material waste, whereas using 3D printing, we can optimize our material use. As written here, 3D printing also has greater efficiency, sustainability, and design flexibility. So now moving next, here are some references we followed. So next is evolution of 3D printing materials. So first is material advancement. So as we discussed earlier, the 3D printing technology can be used for different type of material. So initially it is used only for plastic material, but now due to excess scalability, we can use for different varieties of material like ceramic and concrete. So next is market growth. So according to 2023 data, the 3D printing global market is exceeded $13 billion, and it's and predicted that around 2028 it is cross around $60 billion. So next is construction research. Nowadays, most of research are going on to create the most efficient and economic model of 3D printing so that we can design our structures very precisely. So now talking about traditional construction technologies, to construct more complex and streamlined structures, we face many challenges. But due to use of 3D printing, we are able to push up these challenges. So moving next. So here are some research. So a team led by these 4 researchers create a 3D printing building structure. So the main objective of this research is regarding the study of technical and environmental aspects of the 3D printing. It also covers the economic aspect of 3D printing. So next is system overview. So the 3D printing system is built upon a track vehicle. It can move in both direction, in longitudinal direction and also in lateral direction also. This can be connected with robotic arms, which enables it meticulous control over the construction nozzles. So such a configuration guarantees unparalleled precision and efficiency throughout the printing process. This ensures the accurate fabrication of building structures. The integration of advanced robotics by a research team push the boundaries of construction technology, laying the groundwork for more sophisticated and streamlined building fabrication methods. So next is flexibility skill. So previously the 3D printing only limited for a specific size of structure. Means we can build a specific size of structure with previously, but due to excess flexibility and scalability, now we are able to build from small scale structure to large scale building also. So this innovative approach by researchers signifies a significant departure from conventional 3D printing system and revolutionize the fabrication of object and building on a ground scale. So next is proof of 3D printing. So to prove the concept, the team create a dome structure which is around 50-foot diameter and 12 feet high. They can complete the structure within 14 hours. So this shows a remarkable first and a testament to system potential for rapid and efficient construction showcase. It, it real world application capabilities. So now I would like to call Sivranjan to describe further.
So continuing further, talking about adaptability and sustainability, the researcher system is designed with adaptability and sustainability in mind, allowing it to integrate smoothly into existing building sites and equipment configurations. We can say a site of any size and shape uh, can be used to make a structure using 3D printing of concrete. This integration reduces the need for costly modifications to infrastructure, presenting a more economical option for construction projects. Furthermore, we can say by utilizing local materials and renewable energy resources, the system enhances its environmental sustainability, minimizing its overall impact and cost also. Their dedication to environmental conscious construction practices align with broader industry trends towards sustainability and resource conservation, marking a positive step forward in construction technology. Talking about potential applications, the system boasts diverse and expensive applications poised to revolutionize construction across various sectors. Uh, its capabilities offer potential in transforming disaster relief endeavors by swiftly producing emergency shelters and infrastructure in affected regions within real world. Housing structures can also be made using 3D printing of concrete. Many may wonder how can we make real housing structures as concrete is weak in tension. I would like to mention that in nowadays scenario, we can also plant reinforcement. We can also plant reinforcement along with the printing using 3D printing technology. Moving on to future vision. So now talking about future vision, the researchers envision a future where autonomous construction system utilize environmental data, enhance building design efficiently. So now we can also take inputs to different places where we build different structures and program the printing process accordingly. The shift towards data-driven construction holds the potential to revolutionize the industry, bringing transformative advantages to both terrestrial projects and extraterrestrial exploration missions. Architectural innovations. The research promotes architectural innovation by questioning traditional norms and practices. As you can see in the pictures in the right side, these kind of structures by conventional method is nearly impossible to make, as the norms and practices don't allow these structures. But by 3D printing technologies, we can make these structures and other structures with different innovational designs. Uh, this capacity opens up fresh opportunities for creative expression in design, allowing architects to explore new frontiers in construction possibilities. Moving on to complex shapes and functions, the system offers unmatched design flexibility, effortless producing intricate shapes, overhangs, and integrate features. Its ability to construct complex structures defies the traditional limitations in construction, empowering architects to pursue innovative designs. Additionally, the system's incorporation of wiring and plumbing during construction improves efficiency by simplifying the building process. And this I also mentioned about the planting of reinforcement also. The technology developed by the researchers marks a substantial progress in construction methodologies, enabling architects to execute ambitious designs with enhanced ease and accuracy. Talking about safety and efficiency, is this is a totally machine dependent work. Safety is very important as well as efficiency too. The researcher system outperforms conventional construction methods by improving safety measures, decreasing labor requirements, and minimizing material waste. Incorporating advanced technologies guarantees a safer work environment, lowering risk linked to manual labor and construction operations. Many of you must have heard about accident in construction sites. This can be avoided using machines and 3D printing technologies. Through process optimization and task automation, the system notably diminishes the need for labor, enhancing workforce productivity. Moreover, the decrease in material waste results in cost reduction and environmental advantages, rendering the researcher system a more sustainable and economical viable option for construction endeavors. Now, I would like to invite Satya Satak to continue the presentation.
So thank you, Subramanian, for inviting me. Good afternoon, sir, and hello, everyone. Myself, Satya Sarthak, and to carry forward our presentation, I will start with biological inspired design. So it is something that inspired by nature. The system leads the way in developing creative solutions that blend functionally, sustainability, uh, and aesthetics seamless in building design. By mimicking biological process and forms, the researchers' approach provide a comprehensive model of crafting buildings that are efficient and visually appealing. This shift in perspective represents a notable progression in architectural theory and applications, prompting a greater fusion of natural principles into the build of environment for a more sustainable and harmonious future. It is something that by doing this, we aim to make concrete printing more effective and using fewer resources while creating stronger and more durable structure. So by this, like we minimize our waste and also maximize the productivity, and this also enhance the eco-friendly nature of our 3D printing. So moving forward, uh, we can see the integration of environmental data. Like these researchers utilize environmental data to refine building design, enabling instant adjustment for improved performance. Embedded sensors within the system track crucial factors like temperature, light, and humidity levels. This ongoing monitoring empowers the system to make adaptive changes, guaranteeing optimal conditions for both comfort and efficiency. Harnessing environmental data, the researchers' methods showcasing a proactive stance in building design, emphasizing occupant well-being and environmental sustainability. So by integrating environmental, what we can do, like we can make the concrete printing process more efficient, like reduce waste and create structures that are better suited for their surroundings. Like this help us building more sustainable and environmental friendly infrastructure. Uh, so moving forward, you can see the material diversity here. Like the system offers a wide array of printable materials, including foam, insulation, concrete, and potentially biological enhanced materials. This extensive material selection broadens the scope of construction options, facilitating the development of inventive and eco-friendly building solutions. Whether it's for lightweight insulation or sturdy structural components, the system provides adaptability to address various construction requirements. Like by diversifying the material we used in 3D printing concrete, engineers can enhance properties such as strength, durability, flexibility, and sustainability. So this enables the creation of structures that are better suited for specific applications, environments, and performance requirement. So now come to collaboration with existing building codes. It is something like the researcher system integrates smoothly with prevailing building codes, ensuring compliance with regulatory norms. This alignment with established code reduces obstacle to adoption, simplifying the incorporation of system into traditional construction methodologies. By upholding regularity standards, the researcher approach instills trust in the safety and dependability of the constructed structures. The system capacity to operate within existing framework foster board acceptance and expedites its deployment throughout the construction sector. So this collaboration help us to facilitate the adaptation of 3D printing of concrete in construction projects while maintaining the necessary standards for building safety and compliance. So with this, let's come to the economic factor. Like it is something if you have a fixed amount of budget for some project, and we have to divide the budget or divide the capital into major aspects. So here are a few major aspects like labor, material, and equipments. So labor costs and material costs and equipment cost as the uh, important aspect of our project or a construction for a structure. So like coming to the labor cost, uh, it is something like uh, it referred to the expenses associated with the employing workers to complete the concrete work. Like the it varies with if we have a large project, big project. So the labor number will be more, and we will require more number of capital for the commencement of the labor. So it vary with the size of the project or the technical. If we have a technical project which required more number of skilled labor, so we have to pay more capital to the skilled labor. So this also varying with the skill technical project and also the size of the project. Then coming to the material costs, it is something that we have to purchase for our construction, and like how if we uh, choose a destination which is far away from the market to transport these materials, it also needs some cost. So material cost can fluctuate based on the factors such as market price, quality of materials, transportation cost, and the project specification. Then coming to the equipment cost refer to the expenses that are associated with the machinery, tools, and equipment for the concrete work. So this also can varies with the rates, the maintenance expenses. If we uh, take the equipments in a rental rate, so the duration of the equipment uses during the construction project also matters. And like if we take the project to a very long or a great extent of the time, it will be something like directly proportional with the duration of the our project. With this, at last but not the least, this I want to conclude by this groundbreaking research on 3D printing in construction marks a monumental leap forward for the industry, offering unprecedented opportunity for innovation, sustainability, and social impact. By pursuing the boundaries of traditional construction method and embracing cutting-edge technology, MIT has paved the way for future where building design is not only more efficient and cost-effective, but also more harmonious with the environment and responsive to the need of community worldwide. So with this, myself Satya Sarthak and my fellow teammates Subhasis and Sivaranjan are here. we will combinedly thanking you, sir, for giving us a interesting topic on our concrete technology. So with this,